we are back with our classes on alcohol, phenols and ethers. We finished the nomenclature of alcohols, aliphatic alcohols, phenols and ethers. You know that in alcohols, no two OH group should be attached to the same carbon atom. Alcohols are basically named as alkanols. If there are two OH group, they are named as alkendiols, and if there are three OH group, they are named as alkentriols. We studied the example of polyhydroxy alcohol as sorbitol, which has 6 carbon atoms and 6 OH groups. We also studied different phenols. Monohydric phenol is phenol, cresol, which is orthocresol, paracresol and metacresol. Dihydric phenols we studied catechol, resorcinol and hydroxyphenol. And in trihydric phenol we studied fluorocosinol and pyridinol. Now we have to study the structure of functional groups. That is, we have to study the structure of OH group and the structure of, first we will talk about ROH or the structure of alcoholic group. Then we have to also study the structure of ethers. Every time we start a lecture, whether it is for phenols, whether it is for ethers, we will study that part. As we are doing aliphatic alcohols now, we will concentrate mainly on the structure of alcohol. Always understand, when I write ROH or when I write CH3OH, the carbon is what hybridized? sp3 hybridized. This atom or this orbital of carbon, which is an sp3 hybridized orbital, overlaps with an sp3 hybridized orbital of oxygen. Okay, and the angle which is made is slightly lesser than the tetrahedral angle. So I will read and then again explain. In alcohol, the oxygen of the OH group is attached to the carbon by the sigma bond. Understand here, this carbon-oxygen bond is what bond? Sigma bond. It is formed by an overlap of an sp3 hybridized carbon with an sp3 hybridized orbital of the oxygen. Formed by the overlap of sp3 hybridized orbital of carbon with an sp3 hybridized orbital of oxygen. Clear? The bond angle in COH in alcohols is slightly less than the tetrahedral bond angle. Let us understand. When I draw this is O. It has how many lone pair electrons? 2 lone pair electrons. This is the carbon and this is the hydrogen. This bond angle is lesser than the tetrahedral bond angle of 109 degree 28 minutes. This happens due to what? Lone pair repulsion. It is due to the repulsion between the unshared electron pairs of oxygen. So, please write in your notebook structure of ROH group. Please write structure of ROH group. Please write first point. The carbon-oxygen bond of the COH group. The carbon-oxygen bond of the COH group is a sigma bond formed. By the overlap of sp3 hybridized carbon. By the overlap of sp3 hybridized carbon with the sp3 hybrid orbital of oxygen. With sp3 hybridized orbital of oxygen. Now the second point in this, what is a normal bond angle in case of a tetrahedral angle? 109 degree 28 minutes. Here the angle is 108.9 degree. Please write. Inge baribeku. The carbon OH bond angle. The carbon OH bond angle is slightly less than 109 degree 28 minutes due to repulsion between lone pairs of oxygen atom. Due to repulsion between lone pairs of oxygen atom. Okay, it bariyovaga nodi. This bond length is right 96 picometer and this bond length is right 142 picometer. This much should be written when you write structure of OH group. This comes for 2 marks in bold. So what is the structure of OH group or an aliphatic alcoholic group? It says that the carbon-oxygen bond, which is the bond formed between the carbon and the OH group, is a sigma bond formed, which is formed by the overlap of sp3 hybridized carbon to an sp3 hybridized oxygen atom. The carbon-OH bond which is present is the angle which is present is how much? Slightly lesser than the tetrahedral bond angle of 109 degree 28 minutes. This is due to lone pair repulsion which is present on the oxygen atom. This carbon oxygen hydrogen bond length is less, which is 96 picometer, and carbon oxygen bond length is 142 picometer. As we are only studying preparation of what alcohols now? Aliphatic alcohols. We are talking about structure of ROH group. When we start phenols, we will study structure of AROH. What is AROH? Aromatic alcohols. And when we do ethers, we will study the structure of ethers. Now write methods of preparation of aliphatic alcohol. Method of preparation of aliphatic alcohols. So the first method of preparation of alcohol is from alkenes. That also is right hydration of alkenes. It is what? Hydration of alkene, or you can write this reaction as hydration of alkenes in presence of an acid. In presence of an acid, or you can write acid catalyzed hydration. You can write what? Acid catalyzed hydration. So this is what is important from alkenes. Hydration of alkenes in presence of an acid or acid catalyzed hydration. First thing, let us understand the meaning of the term hydration. Hydration means what? Addition of water. To an alkene molecule, I am taking a genetic reaction. This is an alkene, and to it what I add? Water. So HOH. All alkene in presence of what? An acid. All alkenes always give what reaction? Addition reaction. This pi bond will break. One side it will become negatively charged. The other side it will become positively charged. So what will happen? Water also has what? H and OH. Wherever it is negative side, there the positive part will add, and wherever it is positive, the negative part will add. So I will get what compound? C. I am keeping it like this, single bond C, keeping it like this is, and then negative part you will add what? H, and where there was positive part you will add what? OH. So the compound that is formed is what? Alcohol. It is CH3, CH2, OH. Nothing but ethanol is right. This is what kind of alkene we are taking. Is it a symmetrical alkene or an unsymmetrical alkene? It is a symmetrical alkene. Wait before you write. And when I take CH3, CH, propene. This propene, when it reacts with alcohol, it follows what rule? Addition of a reagent to an unsymmetrical alkenes follow what rule? Markovnikov's rule. What does Markovnikov's rule say? The negative part of the reagent goes and attaches itself to that carbon atom across the double bond which has the least number of hydrogen atoms. So we will get a compound what? CH3, CH, OH and CH3. Name of the compound is what? Propane 2-ol. Clear? So hydration of an alkene or an acid catalyzed hydration of an alkene. Which alkene? Unsymmetrical alkene obeys what rule? Markovnikov's rule. What is Markovnikov's rule? The negative part of a reagent goes and attaches itself to that carbon atom across the double bond which has the least number of hydrogen atoms. If it was an anti-Markovnikov rule, where would OH get added? First. So if I get propane 1-ol, it is what? Anti-Markovnikov rule. Anti-Markovnikov rule should always take place in presence of what? Peroxide. Hence called as what effect? Peroxide effect. Please write these two reactions. Done. So always write after this, addition of water to an unsymmetrical alkene follows what rule? Markovnikov's rule. Markovnikov's rule. What is Markovnikov's rule? The negative part of the reagent goes and attaches itself to that carbon across the double bond which has the least number of hydrogen atoms. So the first method of preparation is by acid catalyzed reaction of or acid catalyzed hydration of an alkene. Understood this reaction? Every time you should get an alcohol attached at its second base if you have 3 carbon atoms. Or it will always never be to the terminal carbon. It should be a carbon which is adjacent to the terminal carbon atom and there are 3 carbon atoms. If you have 5 carbon atoms, it depends on the position of the double bond where it is present. Okay. Now coming to mechanism of this reaction. See, when you write your board exam, there has to be one 3-mark question on mechanism. Okay. Either there will be nucleophilic substitution reaction, SN1 or SN2 mechanism, or either this reaction. There is one more mechanism in formation of ethers. So these mechanisms should be by heart. You should not lose marks on writing steps. So please write mechanism of the reaction. Write mechanism of acid catalyzed reaction. Write step 1. ಯಾವಾಗ ಮೆಕ್ಯಾನಿಸಮ್ಗೆ ಸ್ಟೆಪ್ಸ್ ಬರೀಬೇಕು ಹಿಂಗೆ ಬರ್ಕೊಂಡು ಹೋಗಬೇಕು ಹೆಂಗೆ ನಾನು ಹೇಳ್ಕೊಡ್ತಾ ಇದ್ದೀನಿ ಸ್ಟೆಪ್ 1 ಪ್ಲೀಸ್ ರೈಟ್ protonation of an alkene to form carbocation ಬರೀತಾ ಇದ್ದೀನಿ ನೋಡಿ protonation of an alkene to form carbocation. Carbocation is carbon with what charge? Positive charge. To form carbocation by electrophilic attack of H3O plus. What is H3O plus? Hydronium ion. So first thing, why is that H plus required? Everywhere, wherever we wrote the equation, there is H plus. We said it is what reaction? Acid catalyzed reaction. So first step, H2O reacts with H plus. H plus is from where? From acid to generate what? An electrophile H3O plus. First step, H2O reacts with H plus to form what? Hydronium ion or H3O plus. Clear till here? So this is what? My electrophile. You know what are electrophile? Electron loving. Positive species are called as electrophile. Haloalkanes and nucleophilic reactions. These are all what reactions? Electrophilic reactions. Now what happens is I will take an alkene. This alkene will now react with what? H3O plus. Can you think of it? What happens when this reacts with H3O plus? I will write H3O plus first. If you want explanation part, mechanism ಮುಂಚೆ ಓದಿದ್ರೆ ಯಾವಾಗಲಾದರೂ ಒಂಚೂರು ಅರ್ಥ ಆಗುತ್ತೆ. ಎಷ್ಟು ಹಾಕಿ lone pair electrons? Generally oxygen in water molecule has how many lone pair electrons? 2 lone pair electrons. I have already reacted with H plus. So this lone pair electron goes. The oxygen acquires a positive charge. So I have got this as 1 lone pair electron. Now tell me what exactly will happen. The double bond has to break and this entire H3O has to be added. Try writing the structure with the addition of H3O plus. Please write. ಇನ್ನೊಂದು ಹೇಳ್ತಾ ಇದ್ದೀನಿ. What should I generate at the end? A carbocation. Nodi iga. This basically you will find that the double bond breaks. So I will break the double bond. Aita break madadna ಈಗ ಏನಾಗಬೇಕು? I have to remove this as one center, which is what molecule? Water molecule. So now where the H will go? I have removed the water like this, so one H will come and add here. Plus what will I get? I will get H2O and both lone pair electrons come back. So what will we generate? We generate a carbon with a positive charge. This carbon with a positive charge is called as what kind of carbon? Carbocation or carbonium ion. Step 1, I hope it is clear. If you get confused with adding it here, you can even add it at this point. Okay? So there is generation of what? Carbocation. Now let us write step 2. I am writing it here. Please write step 2, nucleophilic attack. Step 2, nucleophilic attack of water on the carbocation. Nucleophilic attack of water on the carbocation. Innondu, whenever you are writing mechanisms, if it is not, you also always should write with what reactions? Reversible reactions. So now what we are trying to do? Nucleophilic attack. On the carbocation. What is attacking? Nucleophilic attack is being done by water molecule, because water is what rich? Electron rich. So let us understand now. We have this as CH3, we have this as plus, and we have to react what? Water to it. Water is what? Nucleophile. Where will this nucleophile center attack? It will come and attack at this point, because this is negative and this is what? Positively charged. So it will form what? It will form a compound CH. You have C will have O, H Either the carbocation positive charge will now shift over what atom? Oxygen atom. And you will have how many lone pair electrons? One lone pair electron. So please write this step. ಬರ್ದಾಯ್ತಾ ಸ್ಟೆಪ್ 3 ಹೇಳ್ಕೊಳ್ಳೋಣ. Done? It should have what arrow? A reversible arrow. Now the last step. Here see, half the alcohol is formed. You know it is what? CH3, CH2, OH plus one H is more. I do not require that H. What is H called as? H plus called as proton. I do not require that proton. So what will be my step 3? Deprotonation. I don't want that proton. I want to give that proton. So deprotonation. Of or deprotonation of proton to form what? An alcohol. Deprotonation to form an alcohol. Ignore it. This all is being done. You have this H, you have CH2, you have an O, you have an H, you have an H. This is positive. This reacts with what? H2O. Now what will it do? It will give back its proton. When it gives back its proton, what do I get? What was the thing which was present here? H3O plus. And the reaction continues. Hydronium ion or H3O plus. Is it clear? The first two reactions will have reversible arrows. Deprotonation will be direct. You will get what? CH3, CH2, OH, and you will get H3O plus. Till you get the hold of it, there is no point in going ahead. I am again telling you, what is my first step? This is my first step. In general, what was my reaction? That if I take CH2, double bond CH2, CH3, CH2, OH. This reaction is done in the presence of what? H plus. So the first thing, generation of an electrophile. This H2O and this H plus react to form what? H3O plus or hydronium ion. This alkene then reacts with H3O plus to form what? Carbocation and H2O. This carbocation and H2O will react to form an intermediate complex. This intermediate complex will deprotonate itself to form alcohol and again to give back what? H3O plus. Very, 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 very important 3-mark question or 3-mark mechanism. Clear? First, generation of electrophile, attack of electrophile on the alkene to form what? Carbocation. Here product ಬಂದಿರುತ್ತೆ ಅದನ್ನ second step ಅಲ್ಲಿ ಮತ್ತೆ react ಮಾಡಿ. Whatever the product is now, they will react to form what? An intermediate complex. This intermediate complex will deprotonate itself to again give the electrophile. Understood? So this is how the entire mechanism takes place. It takes place in 3 steps. First step, generation of a carbocation. Second step, attack of nucleophile, that is water, which is an electron-rich species, on the carbocation to form an intermediate complex. Deprotonation to give you alcohol. Clear? Now write second reaction to form alcohol. Very, very important 2-mark question, which is oxidation or hydroboration. Sorry. Very, very important reaction. Again, it is a reaction. In all our conversions also we will use. Please write the second method is by hydroboration. Oxidation. By hydroboration or oxidation. This is also in relation from alkenes only. You react alkene with borane. Borane andre gotta. What is borane? P block elements. H3BO3 or H3BO. Okay, that is hydroboric acid. What I am talking about is last year borane and diborane. Borane is, like we say, NH3 is ammonia, hydride of nitrogen. Same way, hydride of boron is called what? Borane. BH3. BH3 always exists as a dimer. Dimer andre two molecules together. BH3 plus BH3. It is called what? B2H6. This is called as what? Diborane. So BH3 is the hydride of boron. It is written as BH3. It is always exists in the form of a dimer. So called as what? Diborane or B2H6. Please write. Diborane reacts with alkene to give trialkyl borane, which is oxidized to alcohol, by hydrogen peroxide in presence of aqueous NaOH. Clear? So first step we will see, we are taking what? An unsymmetrical alkene. So we are taking propene. What is propene? CH3, CH, double bond, CH2. This is propene. Pakka? 1, 2, 3 and 1, 4. BH3 can be written as BH2 and an H fold twice. I can write, I have to actually react it with what? B2H6. So I can write this as BH3 twice. BH3 twice is nothing but B2H6. I have removed one H because I have to substitute this H with the alkyl group. So I have removed one H and I have written this compound. Clear? Now every time you will find that this H will be replaced by what? An alkyl group. What will be the formula formed? Think, wherever there is a double bond, there has to be an addition. So where will you get? You will get CH3, CH, single bond CH2. Here it will be BH2 and here it will be H. Write the first step. Then what I did, you understood, I just added. Now I will start replacing. It is an intermediate compound. This, now you react it with one more molecule of an alkene. You react this with one more molecule of an alkene. Fine. If I react this with one more molecule of an alkene, this H will get replaced by another molecule. So I will get what? CH3, CH, CH2, fold twice BH. This This is called as what borane? Dialkyl borane. CH2, no, sorry. It is called as what? Dialkyl borane. I have to make it till where? Till trialkyl borane. So I will again react it with one more molecule. CH3, CH, double bond CH2. So this H also will be replaced. So I get what? CH3, CH2, CH2, whole thrice B. This is called as what? Trialkyl borane. This trialkyl borane, when it is oxidized in presence of H2O2 and OH minus ions. Okay, this trialkyl borane, when it is basically reacted with H2O2. H2O2 is an oxidizing agent in presence of what? Aqueous NaOH. Aqueous NaOH generates what medium? An alkaline medium. It forms what? Alcohol. What is the formula of the alcohol we will get? CH3, CH2, CH2OH. Please write CH3, CH2, CH2OH plus we will get BOH thrice. Name of the compound name? Propane 1-ol.
What is the other two molecules of CH3, CH2, CH2O?
It is, I have to balance this equation. So at the end I will get how many molecules? 3 molecules of this. Because I have added how many molecules? I have taken 1, 2, 3. So I will finally get 3 molecules of propanol and I will get BOH thrice. This is called as what? Hydroboration or oxidation. Actually together it is called as hydroboration oxidation because till this step you are doing hydroboration and the last step you are doing what? Oxidation in presence of aqueous NaOH. Logic? First add it as it is. Then keep on removing this H and adding the molecule. So you will get CH3, CH2, CH2 whole twice, BH. CH3, CH2, CH2 whole thrice, B. And then when you oxidize, you will get alcohol and BOH thrice. This is called as what? Hydroboration oxidation. Second step. But now here it looks that it is against Markovnikov rule. Yes or no? If it was with Markovnikov rule, we would have got what? Second carbon atom. But it is against moving the Markovnikov rule. Now write next method. Okay, which is preferred if they ask between the two? Hydroboration is preferred because the yield of alcohol is more. Please write. Hydroboration is preferred. Hydroboration is preferred over hydration of alkene as the alcohol obtained in this reaction is excellent or has an excellent yield or more alcohol is obtained. More alcohol is obtained. Okay, now the next method we will do it is from carbonyl compounds. From carbonyl compounds. So the third method of preparation of alcohols is from where? From carbonyl compounds. What are carbonyl compounds? What are carbonyl compounds? aldehydes and ketones which have a prominent C double bond O group. This is called as the carbonyl group. So aldehydes and ketones which have a prominent C double bond O group are called as what? Carbonyl compounds. In this only we will study even COOH from carboxylic acid because it also contains what? C double bond O group. So right, first reaction. By reduction of aldehydes and ketones. By reduction of aldehydes and ketones. Right, first by reduction of aldehydes and ketones. Okay, now this is how you have to remember. Till you finish your exams, you should know one thing. Oxidation of alcohol gives aldehyde. Which alcohol? Primary alcohol. Oxidation of primary alcohol gives aldehyde containing the same number of carbon atom and an acid also containing the same number of carbon atom. Alcohol on oxidation gives aldehyde containing the same number of carbon atom and also an acid containing the same number of carbon atom. Now what I am asking you is how to get alcohol. So ulta banda. Acid on reduction gives aldehyde, which on reduction gives alcohol. If I take secondary alcohol, which is, I am writing here again as, I should actually write this like this, RCHOH, R2CHOH. If I take secondary alcohol, these on oxidation gives ketone. And ketones on further oxidation give acid containing one less carbon atom. If I have 3 carbon atom, I will get a ketone also with 3 carbon atom, but I get an acid with 2 carbon atom. Tertiary alcohols are difficult to oxidize, but these on oxidation end up giving an alkene. Its logic should be clear, particularly with CBSE students and even with state board, because lot of times questions are asked based on this logic. So always understand alcohol on oxidation gives aldehyde. Aldehydes on reduction will give alcohol. Just told them. Primary alcohol on oxidation gives aldehyde and an acid containing same number of carbon atom. Secondary alcohol will give ketone and an acid containing one less number of carbon atom. Tertiary alcohols difficult to oxidize. On oxidation it will give alkene. Clear? So now the ulta part we will study. Reduction of aldehydes and ketones. Do you remember any reducing agents last year? Huh? Carbon is a reducing agent in extraction. I am talking about organic reducing agent. The most common organic reducing agent what you use is what? LiAlH4, lithium aluminium hydride. You also reduce in the presence of nickel, platinum, palladium. You also reduce in the presence of sodium and ethyl alcohol. So these are all what? Common reducing agents. Please write. Aldehydes on reduction, both aldehydes and ketones you have to worry. Aldehydes and ketones on reduction in presence of nickel, platinum or palladium give alcohol. Give alcohol. Fine. So the first thing we will study with aldehyde. I have told when you take aldehyde you will get what alcohol? Just now I taught primary alcohol, aldehyde. So aldehyde on reduction will give what? Primary alcohol. ketones on reduction will give what? Secondary alcohol. So let us understand. Aldehyde R, C, double bond O and H. Correct? Reduction means what? Addition of hydrogen or removal of hydrogen. Addition of hydrogen. So reduction means addition of hydrogen. In presence of nickel, let me write here palladium or platinum. What will it form? What will it form? I need an alcohol. What will it form? The double bond will break. This bond breaks. What will happen? One H will come here. Is the carbon satisfied? Is the carbon satisfied? No. So one H will come here. So what will I get the compound? R, C, OH, H and then H. What is this alcohol? Primary alcohol. RCH2OH. So let us do the compound. We will write CH3, C double bond O, H plus H2. In presence of what? Palladium. It will form what? CH3, C, OH, H and H. This is nothing but ethanol. Done? Understood? Aldehyde clear? So aldehydes on reduction will always give you what alcohol? Primary alcohol. Now we will talk about ketones. We talk about what? Ketones. R, C, double bond O, R plus H2. This reaction can also be done in presence of platinum, palladium, nickel, NaBH4, Na with ethanol, any reducing agent. In our textbook it says what? NaBH4. NaBH4 is what? Sodium borohydride. It is called as what? Sodium borohydride. Now let us make this as R dash. Just because it is given in the textbook, I can even use a simple ketone. What will happen? This bond will break, one H will come here and one H will come here. So I will get what? R, C, OH, H and R dash. Understood? Gives what alcohol? Secondary alcohol. It is ending with what? CHOH. So let us understand. CH3, C double bond O, CH3. Name of the compound? Propanol. This, when it reacts with H2 in presence of NaBH4, it forms CH3, COH, CH3 and an H. What is the name of the compound? Propane to all. Please write after that. Reducing agents like LiANH4, I have written all here, LiANH4, Na with ethanol, NaBH4 can be used for reduction of aldehydes and ketone. For reduction of aldehydes and ketones to alcohol. For reduction of aldehydes and ketones to alcohol. So clear? If I want primary alcohol, I should use aldehyde. If I want secondary alcohol, I should use ketone. Very next, by reduction of carboxylic acid and esters. By reduction of carboxylic acid and esters by reduction of carboxylic acids and esters. Please write acids and esters in presence of strong reducing agent. In presence of strong reducing agent like LiAlH4. What is LiAlH4? Lithium aluminium hydride. In presence of LiAlH4 followed by hydrolysis gives primary alcohol. Followed by hydrolysis gives primary alcohol. So, just write very simple equation here. We take what? RCOH. I am reducing it in presence of what? LiAlH4. And after that I am adding to it what? Water. It forms what? See, you should understand how it goes. I am removing this part. Okay, you will add an H here, so you will have an H2 here. So you will get RCH2OH. Plus what will be removed? If I add one more hydrogen here, H2O. So you will get what? RCH2OH. Just write how it is given in the textbook. It is RCOOH on reduction with LiAlH4 followed by hydrolysis gives what? Primary alcohol. Let us understand here CH3COOH. How many carbon atoms? 2 carbon atoms. When it is reduced in presence of LiAlH4 followed by hydrolysis, you will also get an alcohol containing how many carbon atoms? 2 carbon atoms. Primary alcohol, primary. All acids will give an aldehyde and a ketone containing the same number of carbon atoms. Okay, this part clear? Alright, for esters. I said from acid and esters. So the last part from esters. How are acids converted into esters? What is esterification reaction? What is esterification? When an acid reacts with alcohol in presence of acid, it forms what? An ester. Studied in 10th, studied in first year. As esters are what compounds? Fruity smelling compounds. This ester RCOOR' when it is reduced in presence of what reagent? LiAlH4. It forms what? I have 2 RCOOR'. So please understand. This part will be converted into alcohol and the acid part will be converted into alcohol. So I will get 2 alcohols RCH2OH plus R'OH. RCH2OH plus R'OH. We have only one method of preparation left for aliphatic alcohols, which is preparation from Grignard's reagent, which we will do tomorrow, and along with reactions of alcohol. Please read till here and come. Okay? Thank you. If I would have